we have two blocks which are kept on top of each other. This is block number 1, which is 10 kilograms, and we have a block number 2, which is 5 kilograms. It's kept over here, and there is friction between them. The friction over here is given as 0.8. When they give things like that, it just means forget about kinetic and static, they're both the same things. So static friction, maximum static friction is going to be 0.8 times normal force, and even the kinetic friction is going to be the same as the maximum static. Alright, now in our first case, so this is case number 1, there's a 75 Newton force applied over here, and I want to calculate what's the acceleration of these blocks. Now, notice that there are two things possible. One is the applied force carries both the blocks together and they move with the same acceleration. That's one. Or maybe the force is too much and this block starts sliding over this one. We don't know which one's going to be. So what we can do is we're going to start with an assumption. So let's assume that they don't slide. Don't slide, and we'll always solve these problems this way by first assuming they don't slide, because they're easy to solve and they're easy to identify whether the assumption is right or wrong. Well, if they don't slide, they'll accelerate together. It's going to become a constrained motion, and the accelerations of both of them should be the same. That's the constraint if they move together. So let's first calculate what that acceleration is going to be. Well, I can treat this as one big block of 15 kilograms, and so Newton's second law, net force must be equals to mass, that's 15, times acceleration, it's A, and that acceleration is going to be 75 by 15, that is 5 meters per second squared. Now how do I check whether this is going to happen or not? To do that, we have to ask ourselves, what is accelerating this guy and what's accelerating this guy? Well, let's see, how many forces are acting on block number, this block, 5 kilogram block? Well, clearly there's a 75 Newton force acting, but there's another force. Can you identify that? That's frictional force. And the key thing is to understand the direction of the friction. And I told you before what to do. First, imagine if there was no friction, how would it slide? It would have slid this way. And therefore, the 10 kilogram block is going to put a frictional force on the 5 kilogram block this way, backwards. Okay? So if I were to draw a free body diagram for 5 kilogram, it will look like this. There's going to be a forward force of 75 newtons this way. There's going to be a backward force, and that backward force is going to be frictional force. And that backward force would be maximum if maximum force was needed. If that much force is not needed, it would just self-adjust itself. So what we will do is, we'll first calculate how much frictional force is needed for this. Anyways, let's just write down. It's going to be frictional force over here, and the acceleration of the system is 5 meters per second squared. That's the situation for this guy. Similarly, let me draw a free body diagram for this fellow, 10 kilograms. There's only one force acting on 10 kilograms. Notice that because 10 kilogram is asking the 5 kilogram to not accelerate, pull back, the 5 kilogram instead is asking 10 kilograms to go forward. Action equals minus reaction, right? So 5 kilogram is pulling this 10 kilogram object forward. It's the same frictional force acting in the forward direction, this way. I hope you can really understand this. These two are action-reaction pairs. And that friction has to accelerate this guy all the way to 5 meters per second squared. And what we need to check now is the friction, whether friction is capable of doing it. We can either check it over here, or we can check it over here. I find this is easier because there's only one force, so let's do a quick check over here. The required frictional force is 5 times 10. Mass times acceleration. So it has to be 50 newtons. Can friction be 50 newtons? Let's see. What's the maximum frictional force available? Well, that's mu s times n. N has to be the normal reaction force at this point, because friction is acting at that point, and that reaction force must be equal to mg of this guy, so that is just 50 newtons. So the maximum available force is 0.8 into 50. 40 newtons. You see, that's the max. I'm sorry, that's not gonna happen. So this assumption won't work. So clearly these guys will slide with respect to each other. So this is not gonna happen. So now let's see what is going to happen. So let's redraw this. Might look tedious, but with a little practice, we will be able to do this in few steps. Alright, let's redo this. We had 10 kg, 5 kg, 75 newtons this way. Okay, we now know that they will not accelerate together. So what's going to be the acceleration of each block? Let's quickly draw free body diagrams. There's going to be a 75 Newton this way, and there's going to be maximum frictional force this way. Remember, friction is trying its best to make these guys go together. Friction just hates them sliding. And since the required friction is just too much, friction is going to just become maximum. And that maximum friction we just calculated, that's going to be 40 newtons, right? That's mu s 0.8 times 50, that's 40. Okay, so what's going to be the acceleration? Well, F equals ma. So 75 minus 40 is equal to m times a. And so the acceleration of this guy is going to be, I'm just going to call this as block 1 and block 2. So acceleration of the first fellow is going to be 75 minus 40, that's 35 divided by 5, that's 7 meters per second squared. That's the acceleration this fellow is going to get. Okay, what's the acceleration that the second guy is going to get? Well, the frictional force is going to be again 40 newtons. So that's quite easy. A2 is going to be 40 divided by 10. F equals ma, right? So that's 4 meters per second square. Voila, there we have it. This is going to be the acceleration of the second block, and this is going to be the acceleration of the first block. We could also calculate what's the acceleration of the first block with respect to second block. It's not asked, but we can do that. We can show off. That's going to be 7 minus 4. Remember, it's acceleration of first block minus acceleration of the second block, relative accelerations. So that's going to be 3 meters per second squared, which means with respect to 10, 5 kilogram appears to be moving at 3 meters per second square this way. It's going to overtake and eventually it's going to fall down. That's what's going to happen in this case.